This conference will now be recorded.
Okay, guys, good morning. In today's session, let's start with something called non-primitive casting. That's called typecasting. In typecasting, we have two categories of typecasting. One is primitive typecasting. The other one is called non-primitive typecasting. So primitive typecasting we discussed in our last session. So in today's session, let's talk about non-primitive non-primitive typecasting. Are you clear? And remember, this is going to be such an important concept. This is extremely useful and required for you to understand API development, game development, right? J2EE, JDBC, anything and everything related to Java is purely dependent on this non-primitive typecasting. Are you clear? Hence, don't neglect this session. It's very, very important. Okay. So now I'm going to switch off my camera mode, right? So that you could only hear my voice and whatever I write. Now let's start. Very important thing. Just to start with, before I actually start with non-primitive casting, if I give you an example of primitive casting, which we discussed in our last class, right? Hold on. So let's say I have integer I equal to 10, right? So it means to say I have a variable called 10, and what is the data type of this variable? Integer, right? So we know that as per the diagram, the smaller data type, there are 4 data types, especially 2, 3, 4 data type, and the smaller one is called the byte. The next to the byte is called short, and next to the short is called integer. Next to the integer is called as long. So these are all the data types that we do have in integer data types, right? So can I call all of them as primitive data type, right? So byte is having only 1 byte of capacity, whereas short has got 2 bytes of capacity. So similarly, this has got 4 bytes and long is going to have 8 bytes, right? We discussed it much in detail in our last class, right? So similarly, if I assign I to another variable called as, let's say, integer j equal to I, what am I doing here? I'm assigning I to j. So I is storing a data called 10. I'm going to assign this into j, right? So what is the data that, so I gets assigned to j. Now what's the data stored in j? So the data stored in j is also I. So this simple concept is called, what do you call this concept as? Variable assignment. What is that? This is called a variable assignment, right? And if you closely observe, we are not converting this data type. Because data type of I is integer. Similarly, the data type of j is also integer. So we are not converting from one data type to other. We are simply assigning one variable to other. Hence, this is not called as variable or typecasting. It is simply called as variable assignment. So then what is the meaning of this? What is the meaning of this typecasting? Right, typecasting means what? Converting data type from one to other is called as typecasting, isn't it? So when you have int I equal to 10, if I by chance assign it into a bigger variable called long L equal to I, so now what's the value stored in I? The value stored in I is going to be 10, and I'm assigning that into long. The data type of long is, what is the data type of long here? Long data type, sorry, what is the data type of L? L data type is going to be long. Long is same as integer, certainly low. Long is bigger than the integer. So right side we have I, Observe right side, we do have I, which is little smaller. Left side, we have L, which is bigger one, right? So you are increasing the scope. This concept is called as widening. This concept is called as widening, right? So here you're assigning the value of I to L. The value of I is 10. You're assigning that into L. So what's the value of L now? Of course, it is 10. So this is the concept that we learned in last class, and this concept is called widening. And this widening concept comes under something called typecasting and converting the data type from int to long. There are two different data types are available here, right? This is the concept that we learned in last class, right? So in today's class, let us talk about the similar concept, but with respect to non-primitive data type. I'll repeat, today we're going to talk about the same concept, that is nothing but conversion of one data type to other data type, nothing but typecasting, but let's consider non-primitive data type, okay? Let me explain this. So heading of this concept is called typecasting. Typecasting. Which type of typecasting? Non-primitive typecasting. Non-primitive typecasting, right? In non-primitive typecasting, we do have two types. One is called upcasting. One is called upcasting. The second one is called as downcasting. All right. Upcasting and downcasting. Let's talk about this upcasting. Firstly, we're going to start with the understanding of what is the meaning of upcasting. All right. So this is going to be tricksy. Okay. Understanding of upcasting is simple, but understanding of downcasting is little tricky. Okay. So you have to be careful. So let's start with something called upcasting. Right? So now you should know one thing here. What is the meaning of, tell me, what is the meaning of non-primitive data type? In Java, what is the meaning of non-primitive data type? Right? Just message me in the chat box. What is the meaning of non-primitive data type? Yes, it's called user-defined. Someone by name, what's his name? It's a good name. Someone with a name called James. Okay, LeBron James. Okay, looks like some Hollywood name. Oh, good. Yes, it's called user-defined data type. Correct, user-defined data type. And I do have one more question. And how do you define your own data type in Java? Come on. How do you define your own data type in Java? Come on, I'm expecting you to answer by creating a class. Correct. Super. By creating a class. Yes. Okay, fine, super. Everyone are answering properly by creating the class. Super. When we write a class, the class is called as a data type, and which is called as user-defined data type or non-primitive data type. I have one more question. There is a student who is participating here by name Ashwatthama. Ashwatthama, are you not busy with shooting? Because Mahabharat is there retelecasting Mahabharat, it seems. So, okay, fine. Okay, Shwetama, no problem. I appreciate your efforts of balancing both your, shooting plus you are also balancing with my class. That's very much appreciated. Okay, fine. Jokes apart, let's move on to the concept. Okay, good. Thank you. So I'm going to minimize this chat window now. I'm not able to see your chat window, so please focus. Now observe. A very important concept. Observe. Now I am going to create a class, right? And the class is called as a data type, right? I create a class, for example, I create a class called as employee. I create a class called as employee. So this employee class is considered as a data type. So user defined data type or custom data type, right? So when I do that, when I do that, this is a non-primitive data type because it is a class. Now, how do I create a variable with data type called employee? This is the way that I do it. Employee, even what is there on the right side does not matter, right? It doesn't matter what is there on the right side. Of course, some values must be there, all right? So when I say employee E1 equal to what is there on the right side does not matter. I can simply say employee even, right? So this even can be null also. I can assign a value called null into that, or I can also assign a value called new employee. Either of the one, that's my choice, right? So to put it in a simple way, I can write it in this way. Employee even, I just declared a variable. So closely observe this variable. Even is a variable. What's the data type of even? Employee, right? So it's called non-primitive data type or user-defined data type. So data type is in short, called as simply type. If someone asks, what is the type of even? You should say even is of type employee. Right? So I just declared a variable. Now, what do you really do with this variable? It's up to you. You can use it in different ways. You can initialize this into null. You can just say even equal to null, or you can also write this in this way, even equal to new employee, right? It's up to you. How do you do it? So if I start writing the program for both the versions, right? So this part looks like this. This part looks like this. Employee, employee even equal to null. This is how it look like. And this part looks like this. Employee, employee even equal to new employee. New employee. I hope you understood. So this is called variable declaration and this is called variable initialization. What am I doing here? Uh, Here I'm just initializing it, right? I'll use some different colors here. Not getting the right colors. Yeah, I'm going to use this color. Okay. So here, this part is called as initialization. This is called initialization. Here, this part, observe that there is an assignment operator. Hence, this portion is called as initialization. All right. Now we have simply declared a variable and also we have initialized the variable. Now let's consider this concept and let's see what is the meaning of variable assignment. So quickly answer me in the chat window that did I cover something called garbage collection for you guys? Did I teach you garbage collection in your regular class? Yes, super. Very good. Thank you. So now we're going to talk about variable assignment. Okay, good. Thank you. Fine. Now observe. Thank you. Now observe. What am I going to do now is let me create let me create a class. That example is over, okay? The previous example over. Now let me take another example. So because if I take the same old example, it sounds to be bored, okay? So I'll create one more example like this. I write a class called as product class. I write a class called as product. What are the two meanings of this? The first meaning, it's a blueprint. Class means blueprint. Second means it's called a non-primitive data type, isn't it? Non-primitive data type. Data type is also called as type. All right. So now I'm going to create a variable product p equal to new product. I need little highlighter, eraser. Wait a minute. Not much comfortable of using this. How to go back to this? I want a selector. How to go back to the selector here? Okay. Okay, please observe, guys. So I have something called product p equal to new product. So what is p? P is a variable. What does p do? P just stores the data. What is the data that it stores? Nothing but right now. So object identity. It stores object identity. In simple words, it is going to store an address. Actually speaking, in reality, guys, in reality, in Java, basically in Java, we don't have an access to the object address. I mean, surprisingly, when you create an object, obviously object is created in the heap memory, isn't it? In the heap memory, definitely object has an address, but we don't have an access to that address, right? That's why we say programmatically, when we create an object, there are three things in that. One is called states, right? States. Another one is called behaviors, right? The third one is called object identity. Object identity. Let's talk about this concept separately. So a variable, nothing but a reference, only stores this object identity. Using that, it is going to refer to that particular object, but object address cannot be accessed in Java directly. That's why we call Java as a very secure language. That's an actual reality. Okay. Anyhow, 2, 3D, 1A, let's say this is an object identity. It's an object of which class? Product class, right? So now what I'm going to do, I'm going to store, there's a variable called P. It's going to store this 2, 3D, 1A. So this is how it is, right? Now observe, guys, please observe the variable called P. What's the data type of P? The data type of P is product. That's the data type of P, right? Now I assign this into another variable, something like this. Now I assign this into another variable like product P2. For easy understanding, I call it as P1. So now I assign P1 to P2. Now can I call it as variable assignment? Because you're assigning, this is assignment operator, I'm assigning one variable to another variable. Now observe, yesterday we learned the rule that whenever you assign variable from one to other, the rule is that left side should be greater than or equal to right side. The second rule says that if by chance left side is smaller than right side, then you should use casting. These are all the two rules that we learned. This is called rule number 1, right? This is called rule number 2. These are all the two rules that we learned in our previous session. Now apply this rule, right? Simply apply this rule. What's the data type of P1? The data type of P1 is product. Similarly, what's the data type of P2? P2 data type is also product. Hence, we have two variables with the same data type. So data type matches now. This is called variable assignment, but this is not called as casting. This is simply called as variable assignment. Are you clear? So now programmatically how it works, Now P2 is a variable. What is the type of P2? Product. So P2 is a variable, and what is being assigned in assignment? Assignment operator works from right to left, isn't it? Assignment operator works from right to left. So P1 is on the right side and P2 they're on the left side, right? This is on the right side, this is on the left side. So what is assigned? P1 is assigned to P2, hence the value which is stored in P1. What is the value that is stored in P1? This is the value that is being assigned to whom? P2. Hence, what's the value of P2 here? P2 value is 23D1A. Hence, P2 also refers to the same object. Now observe Maja. So I have only one object in the heap memory. I have one object in the heap memory, but that object is having multiple references. So this is another conclusion that one object in the heap memory, one object can have multiple references, can have multiple references. Extremely important note that one object in the heap memory can have multiple references, and we already learned it. This is not something special. So, sir, why have you repeated for half an hour, which has already been taught before? Observe this concept. As like I started while starting this session, I said that this is super important concept, and this is going to be useful in all the further concepts of Java, like API development, web services, Spring, Hibernate, anything and everything developed in Java, all right, it is going to be developed in Java uses this concept. Hence it is extremely important. That is the reason I had to give you the recap of this session. Are you clear? Now let's apply the typecasting concept here. That's converting the data type from one to other. All right. Before I actually start, I just wanted to quickly ask you, do you have still any questions on this? Okay, great. Super. So most of you are answering no. That's really great. So now I think you can easily understand my next concept. Okay, good. I'm going to minimize it again. Now let's start. Now observe. I have a class. I have a class called as a vehicle. Simple example, I have a class called vehicle. What are the two meanings of this? It's a data type. Another meaning is it's a blueprint. So now I do have one more subclass for this called as the car, which is going to extends vehicle. Okay. The superclass is called vehicle and the subclass is called car. Let's imagine that I'm going to write one more subclass for this. The name of that subclass is, let's say, the name of the subclass is electric car. Okay, so now I have one more class called as electric car. Electric car. This is going to extend. Now the tricky thing starts from here. Okay, the electric car is going to extend the car. Can I call it as inheritance hierarchy? If I start writing this in the form of the diagram, okay, so my diagram looks like this. I have a class. I have one class which is extended, let's say this is extended by one more class, that is extended by one more class, and that is extended by one more class. Just observe here, I have a class called electric car. Electric car extends. What is the superclass of electric car? Car. What is the superclass of car? Vehicle. What is the superclass of vehicle? We know obviously it's an object class, right? So can I call it as inheritance hierarchy? Right? Super. So data type, data type, data type, data type. All right. So you can compare, just for comparison, not in the reality, just for comparison, you can compare this like a byte. What is the bigger data type of byte? Short. What's the bigger to the short? We have something called integer. What's bigger to the integer? Long. So this is just for comparison, okay? Byte is a data type, bigger to data type, bigger to byte is short, bigger to short is integer, bigger to the integer is yar. What's there bigger? Uh-oh, hold on, it went down. What is bigger to the integer? Of course, long. Yeah, is cool. How do I just put this? It's not going on the other side, it is in between anyhow. Okay. So basically the bigger to the long is, so bigger to the integer is long. Okay, this is only for comparison purpose. Okay. So we can easily understand, okay, this is going to be very tricky now. Please observe, don't deviate, concentrate. We have a data type called byte. We say bigger to the byte is short. What factor makes you to say short is bigger than byte? Which factor makes you to say that it is bigger than short is bigger than byte? The only factor which decides that short is bigger than byte is short is having byte is having 1 byte of memory. What is a memory for byte? The byte memory is 1 byte, right? This is 1 byte of memory. What is the capacity of short? 2 bytes of memory. So the memory is telling, right? The memory is the factor. Short is having 2 bytes, byte is having only 1 byte, integer is having 4 bytes, and long is going to be have how many bytes for long? 8 bytes. So the memory capacity is deciding here. So decision factor or deciding factor is the memory capacity. Are you able to understand now? So memory is the decision maker. Since the higher memory, we call it as higher data types. But this is going to be the biggest problem in a non-primitive data type. If we cannot say, what is the memory capacity of car? What is the memory capacity of vehicle? This memory capacity is not applicable for non-primitive data type, which I clearly explained you long back when I was explaining, when I was introducing you to something called non-primitive data type, right? So observe now, short is a primitive data type, which says that 2 bytes of memory and the range of values are -3 to 768 to +3 to 767. It means to say there is something called range of values is applicable for primitive. All right, this is called primitive. The range of values is applicable. Second thing, memory capacity, that is called size, is also applicable. For primitive data type, two things are applicable. The first one is called size and the range of value. Similarly, when I call it as non-primitive, when I say non-primitive, an example here for non-primitive, let's say in my case, it's going to be car or anything, all right? So when I say car here, for that car, size is not applicable. Similarly, range is not applicable. So understood now? So size and range of values are applicable only for primitive, but not applicable for non-primitive. Then on what factor we call the car is the bigger data type to electric car. Now observe, electric car is one data type. The bigger to the electric car is car. This is the bigger data type. This is the bigger data type, and this is the biggest data type. So the question on what factor we say car is a bigger data type. See guys, car is a class, electric car, vehicle, object. These are all classes and classes are non-primitive data type, right? So you have to understand the first and foremost thing. The superclass is the bigger data type of subclass. The superclass is the bigger data type of its subclass. All the superclasses are the bigger data type compared to its subclasses. The reason is pretty simple, right? All the cars can be considered as vehicle, but all the vehicles are not car. I'll repeat this once again. all the cars can be considered as vehicle, right? You found let's say 100 cars. All 100 cars can be considered as vehicle, but all the vehicles are not car, because you may find bike is not a car. You may find auto rickshaw is not a car. So this is a statement: all the cars can be considered as vehicle, but all the vehicle cannot be considered as a car. So that's why a superclass is considered as a bigger data type to its subclass. Are you clear? Now, all the vehicle can be considered as an object. Yes, because object is a real world entity. Any vehicle you find, it can be considered as an object. Any car that you found can be considered as an object. Any electric car can also be considered as an object. So the supermost class is a common data type or the bigger data type for all its subclasses, right? So the conclusion of this discussion here, in case of non-primitive data type, the smaller data type, bigger data type is considered as superclass and its subclass. Okay, based on the superclass and the subclass, we consider the data type as bigger or smaller. All right, just observe. I think only few students have understood it, or few students understood it, but still they expect some more example. So once I give the better example, then probably they might understand it. Okay, just observe now. I have I'm going to create a class, one superclass called as the food. The food. I'm going to write two subclasses for it. One is called roti, right? Another one is called, let's say, pizza. Oh, pizza centers and all totally gone because of Corona. Observe. So one superclass and there are two subclasses, right? So this is a data type, non-primitive data type. Roti, pizza, non-primitive data type, right? Food is also non-primitive data type. Can I call all the rotis as food and all the pizzas as food? Yes. But can I say all the food as roti? No. All the food as pizza? No. Hence, this is called a bigger data type. A bigger type compared to these two, whereas these two are called as smaller type. Understand? These two are called smaller type. So it's a data type, a smaller data type. This is a bigger data type. Got it now? We're going to use this now in writing the program. So quickly in the chat box, if you have any questions, you can ask me before I continue further. Ram has already asked the question that object of electric car, we can't assign object value. Oh, come on, man, there is no full stop, there is no comma. How can I understand? Ram, I didn't even understand what you typed there. It means object of electric car, comma, we cannot assign object value of can't electric car to object of vehicle. Oh, come on, man. Java is easy than understanding your question now. I don't know. Still, I'm not able to understand, Ram. Sorry for it. Okay. Sorry for it. Still, I'm not able to understand it. Let me explain some examples so you may understand it now. Okay. Maybe until that you park your question. So what you do, I'll explain completely this, and after that, still, if you have question, you can ask me that question over this call. Okay, over the call rather than typing. If you find typing is little difficult, you can ask me that question. Mukul, I already answered. Non-primitive data type does not have the capacity. Yes, Deepiksha. The superclass is called the big data type of its subclass. Why? I already answered, Deepshika. Why? I already answered. Because observe, pizza can be considered as a food. That's a generalized form. That's why food is considered as a bigger data type compared to pizza. Roti can be called as food. Hence, food is considered as a bigger data type of roti. So always remember the superclass is the bigger data type of its subclass because roti can be considered as food. So yeah, any other questions? Okay, thank you. I'll continue now. Okay, thank you very much. I'll continue. Please observe. Now let's see the variable assignment here. So on the right side, I'm going to just write only declare variables. Okay, I'm not going to assign any values into it. I'm just rather going to declare only variables. Okay, can I create a variable something like this? Food f. What's the type of f? The type of f is food. The type of f is food, right? Similarly, I'm going to write a variable like this. What is the value stored? It does not matter. It's just a declaration of a variable. Similarly, these are all variables, right? Okay, let me now explain further. Okay, now observe. Now I'm assigning I to L because L is long, L type of L is long. That's L data type is long, which is bigger than int. So it satisfies my rule that left side should be greater than or equal to right side. This is the rule. Let's apply the same rule in our program now. All right. So now what I'm going to do, I create a variable called roti are equal to anything. I can write anything on the right side, does not matter what is there on the right side, right? So now, right now, for example, I'll just take it as new roti. Oh, okay, still to simplify it, I'm going to consider it as null, okay? I'm going to consider it as null. Nothing. Null means nothing. So what's the type of R here? The data type of R is roti. The type of R is roti, right? So can I assign this variable like this? I'm going to create another variable which is of bigger data type like this. Observe, this is called variable assignment. I'm assigning R to F. The variable assignment works from right to left. On the right side, we have, right, on the right side, we have R. I'm assigning R to F, right? So from right to left, assignment works from right to left. So what's the data type of R? Data type of R is roti. Now I'm assigning it into F. What's the data type of F? Food, right? Observe, food is bigger data type of roti. Food is the bigger data type of roti. This is what we learned in here. Food is the bigger data type of roti, right? This is a bigger one compared to this, right? Hence, this variable assignment rule is applicable. Left side should be greater than or equal to right side. So now left side, roti is a smaller data type. I'll write only one dash. So food is bigger than, hence I'm going to write two dash for this, okay? So food is a bigger data type. Understand? So now this is called typecasting, converting the data type from one to other. So R data type is roti, F data type is food. This is what I'm going to do it. I'm converting from one data type to other. So R, okay, sorry, I use this. R is one data type, left side data type is F, right? So the data type of R is roti, and the data type of F is food. which is bigger than that or one level up, right? So now this concept looks like widening. Like this is casting here. This is casting because we are converting from one to other. This is why we call it as casting. And in casting, we are dealing with the non-primitive data type. Because roti and food, they're all not primitive data type, they're all non-primitive data type. All right. And while casting, observe roti is the first step, and like food is upside to the roti or downside to the roti. It is upside to the roti. That's why this is called as upcasting. This is called as upcasting. Casting means conversion of data type from one to other, converting data type from a roti to other. What is that other? The food. All right. So, but food is upside to the roti, hence it is called as upcasting. And this is such an important concept. Now, don't ask me, sir, what is the use and other things. We're going to understand it separately. What are the uses of this? But this is an extremely important concept. Very super important concept. Okay. Hmm. So this is called upcasting. Similarly, I can even write the program like this. Similar to this, I can even write just like this. Pizza P equal to dash 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 dash. What is there on the right side does not matter. The data type, sorry, the data type of P is pizza, right? I'm going to assign this into another variable called food. Food fd equal to P. Now observe again the same old variable assignment, right? Assignment works from right to left. What's the data type of P? Data type of P is pizza. Data type of FD is food. Food is one level higher, right? This is pizza. One level higher to pizza is food, right? Which is upside. Okay, this is up, this is down, right? So now, if you observe this, you're converting from one data type to other. You're converting from one data type to other. What is the data type? So hence, this is called, you have on the right side, we have P, on the left side, we have FD, right? So you're converting P to FD. So since there is a conversion involved, it is called as casting. Casting means conversion from one to other, right? Now, and this is bigger than this. It's nothing but widening or upside. This is present in the upside, hence it is called as upcasting. Are you clear? And it still follows the rule, and the rule says that left side should be greater than or equal to right side. Right side in our case, the right side is pizza, the left side is food, which is bigger than pizza. It works. Okay, just thoroughly go through this example. So now we will definitely understand, sir, here what it is going to be here. What is it? And depends on what is really present here. Does it really affect? It does not really affect, but I will explain you how it works. All right, how it works. I'll explain you how it works. I hope this has given you a better clarity. Uh, no, not possible. Piyush, your answer is wrong. It's not possible. Piyush, not possible. Yes, Prem is perfectly correct, sir. In order to achieve non-primitive casting, inheritance is required. Yes, 100% is required. Remember, for upcasting, It's very important to have inheritance. Without inheritance, you cannot achieve upcasting. Okay, Gaurav is asking me a question that, sir, why do we need casting in the project? So that's a separate chapter, Gaurav. In fact, for the previous batch, that's a morning batch which I take, for them, I spoke about the reason of this casting almost for 2 sessions, 1.5 hours of 2 sessions. I discussed exclusively only on what is a requirement, what is the reason of this upcasting, right? Upcasting and downcasting. So for your batch, I'll share the same video, and super important. Okay, right now let's not worry about what are the uses of it. Right now we concentrate only on what is the meaning of upcasting, not even downcasting today, because more time I spend only on upcasting. So tomorrow's session is going to be on downcasting, right? Please ask me any question if you have. Yes, Aditya Kumar is asking, sir, widening or upcasting, both are same. Logically, functionally same. The way it works is same, but widening is a word which we use in case of primitive casting. Why upcasting is used in case of non-primitive casting. Okay, it's like this. Okay, cutting and chopping are technically same, functionally same, but the usage differs. We use the word chopping when you are cutting some small things like vegetables or anything, right? When you are cutting a bigger tree, you cannot say I'm chopping a tree. You say I'm cutting the tree. It's a contextual, but functionally, meaning wise, they are same, right? Sir, in non-primitive casting, Pooja is asking me a good question. In non-primitive casting, the first rule is applicable, that is left side is greater than or equal to the right side. Is the second rule possible? That is what downcasting, Amma Pooja. That is tomorrow's concept, which is possible. So Pooja asked a really good question. Prem Kumar Chaudhary is again asking a question, sir. Can we consider that size of roti and pizza is same because both are subclasses? No, no. Size does not matter only, Prem, here. It does not matter here. The size does not matter because it does not have size only. So hence forget about talking about the size now. I think I answered almost all the questions which was popped here. Do you have any other questions? Please ask me. Le Mukul, Guldo, 2 minutes before I answered. For someone that inheritance is required to work with upcasting, again he is asking question, without inheritance can we use typecasting? Yeah, nonsense. Now Deepshika stopped stopped asking the question because I already answered. Yeah, do you have any other questions? Please ask me here. Okay, at a time only one subclass upside. Subclass is always at the downside. Subclass is at the downside, not at the upside. Fine, guys. Okay, now I'm just going to minimize this. Let me explain you now the same concept by assigning some value. But here, right now, I have only explained you. I as of now, I've just explained you only by creating a variable and assigning the variable from one to other. But I have not explained you by assigning some data. So now, what I'm going to do, let me explain you by assigning some data into it. Okay, let's see to it. How exactly functionally it works? Wait for a minute, please. I just write a big line here and I'll explain, okay? Now, let's see one more example. Very simple example. I have one superclass. I'm going to call this superclass as pen, okay? And I do have one subclass. Let's not take multiple subclasses. For easy understanding, I'm going to take it as sketch pen. So sketch pen is the subclass which extends the superclass called pen, right? So sketch pen is the subclass and pen is the superclass. Can I call sketch pen as a data type or type? Pen also type. This is called bigger type because it is a superclass, bigger type, and here this is called smaller type. This is called smaller type, right? Okay, good. Now let's see to it. What I'm going to do here is let me create an object of sketch pen like this. Sketch pen sk equal to new sketch pen. Right. Now let's understand what is this sk. Sk is a variable. What's the type of variable? Sketch pen. What's the data type of this variable? Sketch pen, right? Data type. Now how exactly it works now? So sk is a variable which refers to an object which is present in the heap memory. Which is present in the heap memory, right? So sk refers to an object. But object of which class? Observe, new is a keyword which is used to create an object. So it's an object of which class? Sketchpen class. It's an object of sketchpen class, isn't it? Now sk is a reference. Ultimately, it's a variable referring to an object which is there in the heap area, right? And object of which class? Sketchpen class. Let's say 36D is the object representation. 36D is, let's say, an object representation, right? Object identity. So now what I'm going to do, I'm going to assign this sk. Assignment works from right to left. I assign by using an assignment operator. I'm going to assign it into another variable called p, right? This is what assignment is all about. I'm assigning sk to the p. Data type of p can be, observe, data type of p can be sketchpen, or data type of p can be pen, or it can be even superclass object. Three choice. Data type of pen p can be sketchpen, can be pen, can be object. Right? If you look into all these options, it looks like this. All right, just for example, this is a first option. This is going to be a second option. Let's say this is going to be the second option. This is going to be, let's say, the third option. Let me write the code for all the options now. This is going to be the first option. If the first option, it looks like this. Object p equal to sk. This is going to be the first option. How the second option look like? The second option look like this. Second option look like this. That is pen p equal to sk. And the third option look like this. Sketch pen p equal to sk. right? Now observe this thoroughly. You're assigning again and again. I repeat, assignment works from right to left, right to left, and right to left. Carefully observe the data type. The data type of P is object. The data type of P here is pen. The data type of P is sketch pen. All right. But the common thing is that in all the cases, the data type of SK is, what's the data type of SK? Observe this program and tell me what's the data type of SK. The data type of SK is sketch pen, isn't it? The data type of SK is sketch pen. Hence, the data type of here SK in this case, in this case, in this case is going to be sketch pen. Sketch pen. Nothing but, please observe, this is nothing but subclass, okay? It's nothing but the subclass, right? So you're assigning one variable to other. Let's understand one by one, right? In the first case, I wanted this space, okay? That's why I've written it in this way. You're assigning sk to p. Now, what is p? It's a variable, right? So p is a variable. P is a variable. What's the type of p? Object. The p type is not p1, it's called p. Okay, the p type is, okay, you're assigning sk to p. What is the value stored in sk? 36d. Hence p is stored in 36d. Hence p also refer to the same object. In case of this is the story of the first case. Okay, this is the story of first case. What's the story in second and third case? Let's see to it. Okay, the story in second case is you're assigning sk to p. Now observe the rule. In all the cases, you should understand the rule. The rule says that left side should be greater than or equal to right side. Left side data type. Left side data type is object. Right side data type is sketch pen. Correct? This is sketch pen. Data type of SK is sketch pen. Data type of P is object. Hence, object is same as sketch pen. No, object is bigger because it is superclass. So left side data type is bigger than the right side data type in this scenario. All right, in this scenario, in the case number one, left side data type is bigger than the right side data type. In the case number two, let's see how it works. The left side data type is pen and the right side data type is sketch pen. So pen and sketch pen is not same, but the pen is bigger class of sketch pen, hence it is bigger than this, right? In the same way, the last option is third one, right? Here we have the right side. What is the data type of right side? That is SK. SK data type is sketch pen. And what is there on the left side? Left side is also sketch pen. Hence, sketch pen is same as sketch pen. It is same. Hence, the first two option is called as upcasting. I'll repeat, this is called upcasting. This is called upcasting. This is called no casting, because I'm not converting data type from one to other. You call it as casting only when you change the data type from one to other. So here data type is changed from sketch pen to object. Data type is changed from sketch pen to pen. But here I'm not changing any data type from sketch pen to anything else. Rather, it is going to be same in both the scenario. Hence, it is called as no casting. This is not called as casting only. Now again, don't ask me, sir, upcasting or downcasting. It is not casting only, okay? But these two are considered as upcasting, right? So now programmatically, let's say the first case, you're assigning sk to p. Now p is a variable. You're assigning the value of sk. The value of sk is 36d. That has been assigned to p. Hence p also refers to the same object. In case of 2, you're assigning sk value to p, right? In this case also, p is a variable. The value of sk is been assigned, that is nothing but 36d, and this is also referred to the same. right? Here also the same. You want the different names for it. You can call it as P1, you can call it as P2, you can call it as P3, P1, P2, let's say P3, okay? Now, the value of SK is assigned to P3. SK value is 36D, which is assigned, and this is same. It refers to the same object. This is how functionally it works, right? Object is same, but the way of referring that object is different. This is how functionally it works. So functionality wise, you don't have any difference, only the casting wise, that is data type wise, they are different. Just I'm going to pause here myself. I'll not talk for next 10 to 20 seconds. You can observe this code. You can try to understand this. Okay. So now you can ask me questions if you have any in the chat box. Yes, Akash Chatterjee, third case is variable assignment. Yes. Any questions, please? Okay, super. Thank you. Thank you. Now observe. Let's go back to this. Observe here. Let me now give you almost, I'm reaching the conclusion state now, right? Upcasting is nothing but a superclass reference referring to, I'll repeat, upcasting is nothing but a superclass reference referring to any of its subclass object. Okay, I'll repeat, please observe. So upcasting is pretty simple. Upcasting is nothing but the reference, nothing but superclass reference, which is referring to any of its subclass object, any of its subclass object. It may have 100 subclasses, any of its subclass object. That is, the object is from subclass and the reference is from superclass. So this concept is called upcasting. Repeat this entire definition. Upcasting is nothing but a superclass reference referring to any of its subclass object. A superclass reference referring to any of its subclass object is called upcasting. The conclusion is the object is from subclass and the reference is from superclass. So this is called as upcasting, right? So when we talk about this, so many students have a lot of different questions. Or what is the use of this upcasting? Where it is going to be useful, right? So definitely, if this concept is not useful, they wouldn't have given this concept as a programming language, right? In the programming language, they derive into some concepts which is some or the other way useful, correct? So, and here upcasting is greatly useful, not just ordinary useful. This is greatly useful, which we are going to discuss in next two classes of where exactly it is going to be useful. All right. So, but before that, in tomorrow's session, we're going to talk about downcasting. So then we are going to talk about the uses of this upcasting, downcasting with a lot of real-time scenario. So for the previous batch, I explained one small game scenario, like PUBG game scenario. So the same PUBG game scenario video is available, which I'll share with you. Then you will understand. But before that, you should know what is the meaning of downcasting. So downcasting is going to be tomorrow's concept. Okay, so before I conclude today's concept, let me take you through some example, one or two more example of this upcasting. Just have patience, have a look into that examples. Okay. Someone was asking what is the definition of upcasting. The definition of upcasting is that any of its subclass object, that is, reference is from superclass and object is from subclass, right? So that's it. This is the definition of upcasting. A superclass reference referring to any of its subclass object, right? That is, the reference is from superclass and the object is from subclass. That's called upcasting. All right. Now let us see to it with, before I conclude today's session, let us see to it with one or two examples on this, okay? Now, a reference is from superclass. Let's say bird is the superclass. Bird is a superclass equal to new parrot. Parrot is the subclass, bird is the superclass, right? So bird is the superclass, and I'm going to have something called parrot. Parrot is the subclass of bird. So observe, object is from subclass, reference is from superclass. This is an example for upcasting. Similarly, I do have one more example. Vegetable, v equal to, let's say, a new carrot. The carrot is a subclass, vegetable is the superclass. All right, so cloth, c equal to new shirt. Shirt is the subclass, cloth is the superclass. This is an upcasting. Engineer, civil engineer. Okay, this is an example for upcasting. Like this, you can give thousands of examples here. Fruit equal to new mango. So in all these cases, if you observe, this is an object of subclass, subclass object, and these references are from superclass, right? This is called upcasting. Okay, now observe the definition of upcasting. A superclass reference referring to any of its subclass object. A superclass reference referring to subclass object. This is called upcasting. Clear? So that's it for today's session. Thanks for attending, and don't forget to attend tomorrow's class because it's extremely important. I'm going to teach you downcasting and also how this upcasting is going to behave. What are the two main characteristics of this upcasting? Okay, thank you very much. Bye-bye.